Welcome. This is a video about our final project for course AMA 564 Deep Learning. Our group members are Xiao Yijiang, Xian Zongkun, Dong Jiaxin, Wei Yuxuan, and Zhu Tianyu. While the rapid growth of internet news has led to the need for efficient news classification, this paper presents a new classification model based on LSTM using the PaddlePaddle NLP platform. Well, this model performs word segmentation and ID transformation to convert the news corpus into computer-readable one-hot codes. And then utilizes LSTM to capture syntactic features and contextual relationships, generating complete semantic vectors. For the first part of our paper, we talk about the research background significance. Then for the second part, we talk about the research status in China and abroad. In recent years, deep learning approaches have yielded breakthroughs in news classification. Models such as CNN, RNN have been widely adopted, in which CNN effectively capture local features and syntactic information, while RNN handles sequential information and long text. Transformer and the BERT, new deep learning models, incorporate self-attention mechanisms and pre-training techniques have further improved classification performance. And in China, the PaddleNLP framework has empowered researchers with powerful tools for news classification. Meanwhile, foreign institutions and companies have also contributed innovative methods and models.
The next part is Sohu News classification model based on LSTM. Firstly is data preprocessing. We read the dataset into tuples using LoadMyData and split it into training and test set. We check the data by printing the first 5 training samples. Secondly is data segmentation processing. We preprocess the data with data preprocess, which trim space converts to lowercase and splits sentence into words. Next is data set ID conversion. We build a vocabulary with build-dict, mapping words to IDs and counting word frequency. Two special words are assigned IDs 0 and 1. We process the dataset and output the first 10 words in the vocabulary with their IDs and frequencies, and the vocabulary size. We convert words in the dataset to their IDs. Words not in the dictionary are replaced with the OOV ID. We print the number of tokens in the corpus and the first 5 sentences in the training and test corpora. Last is mini batch generation. We create an iterator to generate mini batches for training or prediction. Each mini batch includes 2 tensors.
Next designs a neural network model for new classification called sentiment classifier based on the LSTM network. The sentiment classifier network model is implemented by the following layers: the LSTM layer, the embedding layer, and the 4 connected layer. The LSTM layer will first read the sentence word by word from left to right when processing the sentence and keep calling an identical cell to process the temporal information and another cell to retain in order to read the important information in the content. And then for the forward confunction, the forward confunction is the execution convention of this news classification network. And then we talk about the model training. Before the model training begins, the seeds are first set for 3 different random number generators: the paddle seeds, the random seeds, and NP random seeds. Next, the high parameters used to train model are defined and instantial using the defined sentiment classifier network using the NDEM optimizer to define an optimizer and specify the learning rates and the power parameters. The optimizers will use the backpropagation and gradient descent to update the model parameters during the training.
Next, let's analyze the experimental results. After training and testing, we obtain the confusion matrix and various evaluation matrix of the model: accuracy, precision, recall, and F1 score. The numbers on the diagonal of the confusion matrix represent the number of correctly classified samples for each news categories. Its vertical axis represents the true samples for each news category, which is the ground truth, while the horizontal axis represents the predicted samples for each news category. The total number of samples is 2539. From the first column, we can see that there are a total of 787 car news articles, out of which 769 car news articles are correctly classified. 2 car news articles are misclassified as finance, 2 car news articles are misclassified as IT, and so on. After obtaining the confusion matrix, we can calculate accuracy, precision, recall, and F1 score for each category. We can observe that the accuracy for all 10 categories of Sohu News classification is above 90%. However, in terms of the F1 score metric, the performance of the travel, culture, and health news categories is not good. By observing the confusion matrix, we can see that the culture and travel news categories are easily confused. One possible reason for this could be that culture and travel news often share common terms, such as famous architectural names like the Great Wall and the Forbidden City. Since the gradient descent is already stopped in the model evaluation code, the same terms will be classified into the same news category, resulting in confusion in the classification of the small number of news articles.